Okay, this time we will prove if f is continuous and injective on an interval I, then f is either strictly increasing or strictly decreasing, and we will approach the proof this time by contradiction. We'll prove by contradiction. So, for the sake of contradiction, let's suppose f is not strictly increasing or decreasing. Okay, well, what does that mean? Well, what that would mean is that there would have to be a place where it increased and a place where it decreased, right? Because we know that if it's not going to be only increasing or only decreasing, then that means there must be a place where it goes up and a place where it goes down. So we could say that then there are points x1, x2, and x3 in the interval I with x1 less than x2 less than x3, so I'm forcing order on them here as x1, x2, and x3 in order from left to right, and one of the following, right? Either case 1 or case 2. Case 1, case 2. Case 1 would be that, let's say, it increased first and then decreased along these points, so that would be like saying f of x1 is less than or equal to f of x2, and then it would have to decrease over the next two, so that would be f of x2 is bigger than or equal to f of x3. Or what would the other case be? The other case would be f of x1 bigger than or equal to f of x2. So in other words, it decreased initially and then it eventually increased, and f of x2 then increasing up to f of x3. Okay, we will proceed to show one of these cases and leave the other one for you to do on your own. Just because one comes before two, I'm going to do case 1. So we are going to suppose that the first case is the one that occurs. Let's draw a little sketch so we can make sure we understand exactly what the picture would look like. Remember, I'm forcing x1 less than x2 less than x3. So in our picture, it means that x1, x2, x3 are ordered along the x-axis. The first part of the assumption says f of x1 is less than or equal to f of x2. So here's x1 and its output, and then here's x2 and its output. And then the second part of our assumption, or in this case, is that f of x2 is bigger than or equal to f of x3. So in other words, it decreases to x3. So here's x3, and then f of x3 is going to fall into two different categories, right? We don't know which one of these categories is going to be the case, but f of x3 could either be here, right, decreased a little bit but not beyond where f of x1 was, or it could possibly be down here. It might have decreased all the way down to past f of x1. So we don't know for sure which one of these cases is the case. So actually within case 1 we're going to have two sub-cases. So let's proceed formally now. So case 1. Remember, in case 1 we are supposing that f of x2, wait, I should say suppose, wrong verb form, I guess. Suppose f of x1 is less than or equal to f of x2, and that f of x2 is bigger than or equal to f of x3. You might notice that we said that f was injective, right? It was 1 to 1. So since f is 1 to 1, since f is 1 to 1, since it's injective, f of x1 cannot be f of x2, and f of x2 cannot be f of x3. So we don't repeat the values. So we actually know a little bit stronger. We know that f of x1 is either less than or equal to f of x2, but it's not equal. So f of x1 is actually strictly less than f of x2, and f of x2 is bigger than f of x3. Okay, so as I start to proceed through this case 1 here, as I mentioned in the previous slide with that picture, we're going to have to do a couple subcases. So let's do subcase 1, and in subcase 1 we will say f of x1 is less than f of x3. F of x1 is less than f of x3. So back to the picture, I'm saying f of x1 is less than f of x3. So I am supposing that we are doing this case. This would be the f of x3, because I'm saying f of x1 is less than f of x3, and then we'll just have to do another subcase for when we had the red point instead of the orange one. Okay, subcase 1. So if this is the case, if f of x1 is less than f of x3, what happens then? Then we have what? Let's see, f of x1 less than f of x3, and f of x3 less than f of x2. Right? F of x1 less than f of x3 less than f of x2. But then, remember, it's a continuous function, but then the IVT, the Intermediate Value Theorem, would say there is a C between the x1 and the x2, between x1 and x2, with f of c equaling f of x3. Now, it might not be a problem if c was x3, but remember that c is between x1 and x2, so it can't be x3. So this here is a contradiction. This contradicts that f is 1 to 1. So that's no good. So let's go over into the other subcase. So this subcase was f of x1 is less than f of x3. So let's go subcase 2. And in subcase 2, instead of saying f of x1 is bigger, or what did we say last time? F of x1 less than f of x3. This time we'll say if f of x1 is bigger than f of x3, what's going to happen here? Well, let's go back to our picture and change it now then. So no longer do we have f of x3 here. We now have f of x3 being way down here. F of x3 way down here. Okay, well, if that is the case, if f of x1 is bigger than f of x3, then we have f of x3 was at the low end, so it's lower than f of x1, which was lower than f of x2. But what does the IVT give us now? But now the IVT, the Intermediate Value Theorem, provides a C between where? Between x2 and x3, with f of c being equal to the value in the middle, f of x1. So now we have something in between 2 and 3 that is equal to f of x1, and that's no good. This also contradicts the injectivity of f, the injectivity of f. So that's no good. So both of these subcases prove an MWO on case 1. Now that's half of the proof. The other part of the proof would essentially be very, very similar. So just to remind you of that, if you're going to try it on your own, let's write up what that case would look like. I just did case 1, and the case 2, all the way back to the beginning, was the case down here. So if you're going to proceed to try this on your own, you would have to suppose f of x1 is bigger than or equal to f of x2, and f of x2 was less than or equal to f of x3. That's looking cramped. You'd have to suppose f of x1 is bigger than or equal to f of x2, and f of x2 is less than or equal to f of x3. So get sketching. Draw yourself a little picture and try to reason through it like I did with the first case.